What is the diameter of a 100-meter long copper wire that's found to have a resistance of 0.1 ohms? This is a tricky problem, so we'll walk our way through this. We're given the fact that resistance is rho L over A, so we need to figure out what the diameter is. If I draw a picture of a wire, and that's the area, we know that that area has a radius, and we know the radius is the diameter divided by 2, and the diameter will be 2 times the radius. So let's manipulate this equation and solve it for A first. A is rho L over R. So we could solve for that area, and once we know the area, we could find the radius, and once we know the radius, we could find the diameter. But we could solve this quickly by subbing in quite a few things. We know that area is pi r squared, and that will equal rho L over R. Pi r squared, what is R? R is d divided by 2, as stated here. What is r squared? If I square one side, I just square the other. So we get d squared over 4. So r squared, let's just stick with capitals to be consistent. R squared is d squared over 2. So we get pi times what r squared is, d squared divided by 4 is rho L over R. So now we solve for d squared. When we do this, d squared will be 4 rho L divided by pi r. There's a lot of algebra here, but nothing impossible, especially if we do it together. And to solve for this, we'll simply take the square root of both sides, and we're home free. So that's kind of messy. I'm going to erase to give us a little, no, I'm not going to erase, I take that back. We're just going to slide down. We'll end up with a little more room. I'm going to move this down so we can refer to it as we problem solve, and we'll solve for the diameter. I'll rewrite one more time. Diameter is the square root of 4 times the resistivity divided by the length divided by pi times r, which happens to be the square root of 4 times the resistivity of copper wire. Think back, we have to remember that. That is still 1.68 times 10 to the negative 8. Skipping units for just a moment, times the length, 10 to the 2 meters, that's 100, divided by pi, that's 3.14, sorry about that, times the resistance, 10 to the negative 1 ohms. So this is ohm meters. Let's just write units. Ohm meters times meters divided by ohms. What are ohms divided by ohms? That's 1. What are meters times meters? It's meters squared. Square root of meter squared will be meters. And then this is just a lot of computation. So let's just reveal the answer rather than pulling out the calculator and compare the substitution of the numbers in. So again, we have 4, that works. The resistivity of copper, we're good there. 10 to the 2 is 100 meters. Pi, 3.14 10 to the negative 1 is 0.1. So we end up with 4.625 millimeters. Really, we're going to get an answer in meters and then convert to millimeters. Give this a shot yourself and see if you can compute that. That was intensive because it required a couple things. Number one, we had to start off with the equation for resistance, solve it for area. Once we solve for area, sub in pi r squared. Figure out what the diameter is in terms of the radius, plug that in, and then sub everything in. So when you solve problems like this, you have to have a systematic, calculated approach. Show as much work as possible to keep track of everything, and then wait until the end before you sub in values, and you'll be home free. So again, give this problem a shot. When you're working through difficult problems, find a friend, and often together you'll achieve more.